Hello and welcome to a new section in geometry. This is a unit 9, it should say unit 9, not unit 6, notes on circles. And this is section 1, and this is the introduction to circles. And what I want to do is kind of talk about some vocabulary before we do anything. And a circle, okay, is a figure whose points are equidistant to the center. Okay, so let's write that down. So a circle is a figure whose points are equidistant to the center. Equidistant from the center. All right, and that's the first thing we know. So, and that's the idea. You know, here's the center of our circle, and here is the circle itself. And all of these points have the same distance to the center, okay? So we have some vocabulary that we can talk about, and the main ones that I want to talk about right now, and we'll kind of discuss all of these. But I want to talk about real quick, you know, we have all these different things in the in this picture here, and this kind of depicts what we have in a circle. Okay, first one I want to talk about is the center. Okay, that's the middle point. The radius over here is the distance from the outside of the circle to the center. Okay, the diameter is a length that goes from one side of the circle to the other. Passes through the center, and so those things are things that I feel like we know. A chord is something that's new. Okay, a chord is over here. Chord is something that a line that intersects a circle twice, but does not go through the center. Okay, and so that's what a chord is. Okay, so a chord connects two parts of a circle here, but does not go through the center. It's kind of the same thing as a secant line. Okay, a secant line is something that passes through a circle twice. Okay, it touches the circle at two different points, which is a little bit different than what a tangent line is. A tangent line is a line that hits a circle at exactly one point. Okay, so that's kind of the point of this, is that a tangent line hits it at one point. Okay, a secant line hits a circle at 2 points. Okay. And a chord is a chord is a line that touches it at 2 points. So it's kind of like a secant line. So let's go through and kind of just go through this and talk about what we have. Okay, so a radius of a circle is a segment that extends from the center of a circle to any point on the circle. Okay, so in this example, line LK is my radius. Okay, this is my radius. All right. If you were to talk about line LM, okay, this would be a chord, all right, because it doesn't hit. Now, it could be congruent to the radius, but, that depends on what you have. So, okay, let's take a look. Chords and diameters. So a chord is a segment with both endpoints on a circle. Okay, so it's a segment. So here, if I were to talk about my chord, and I'm going to kind of use this blue example here, HF would be my chord. Okay, so my chord in this example would be line segment HF. Okay, the diameter of is a chord that passes through the center. Okay, so if this was my diameter was here, all right, here's my center point D, and it continues on through that. So I would say that my diameter is segment EG. Okay? All right, the next thing we have are tangents and secants. So a tangent to a circle is a line, or line segment, or ray that intersects a circle at exactly one point. Okay, the point of tangency. Okay, and what I like to think of is like the tire on a car. Okay? Like when you think of a car or a wheel or a tire or anything, when that, I'm just going to draw that example down here. Okay, when you have a car, all right, the point at which the tire hits the road, that, my friends, is your tangent point, okay, is your tangent to that circle. Okay, so PQ, okay, tangent to the circle would be ray PQ, okay, and your point of tangency would be point R, okay? And the other thing that I know about this that isn't really listed on here is that RS is perpendicular to RQ, okay? So that's the other thing that I know, and then this is a radius, okay? All right, so a secant is a line or array that intersects a circle at exactly 2 points. So a secant is something that does that. All right, so intersects at those 2 points, okay, at M and N, okay, not at 1 point. So it's a couple different things that we've got going on here. And, you know, what I want you guys to notice is that, you know, is that this is a lot of vocabulary, okay, and, you know, just understanding the difference between a chord, a diameter, tangents, secants, and a radius, okay, on this page. Okay, let's go look at the next page. Okay, one cool, unique thing about a circle is that all of our circles are similar, okay, and so, you know, what we do and how we get from one circle to the next is basically by a dilation. Okay, and we would dilate a circle by the factor of big R divided by little r, okay? And that's how we get that. So, and these are what we call concentric circles over here. And concentric circles are circles that share a common center. So they share a common center, all right? Okay, now the next thing, let's get in kind of the meat of this, is the relationship between arcs and angle measures, okay? So what we have is we have this circle, and we have this thing called a central angle here. And a central angle is an angle whose vertex is at the center of the circle, okay? And the sides of this angle are radiuses. So I'm just going to come in here and call this a radius R, okay, call this a radius R, okay? And what we have is we end up getting this thing called an arc. And this one is called a minor arc, okay? And a minor arc is usually less than, is usually the small angle, the small arc, okay? And then what you have left is a major arc. Okay, and this is usually the bigger arc. Okay, usually, you know, and you can kind of tell by the minor and the major. Okay, now what I know about a small arc or my minor arc is usually it is less than 180 degrees. Okay, where a minor arc is usually greater than 180 degrees, and that's just kind of the typical thing that we see. Okay. And so what we're going to do is we're going to kind of talk about how we measure these arcs and how we can figure out what those measurements are, okay? And what we know is this, is that the degree measure of an arc is equal to the degree measure of a central angle that it intercepts. So the minor arc, okay, so a minor arc, and this is big, minor arc is equal to the central angle. Okay, and we measure this in degrees, so it's measured in degrees. Okay? All right, let's take a look at what a semicircle is. And a semicircle is where you have an arc that is 180 degrees, okay, where your central angle makes up 180 degrees, okay? So when you have this angle here that's 180 degrees, okay, you know, this arc measure here is also 180 degrees. Okay, so each of those, all right? And so we would okay, so let's kind of talk more about what this is down here. So now down here, it says a minor arc is an arc whose measure is less than 180 degrees. Okay, we've talked about that. Major arc is an arc who's greater than 180 degrees. And what we do is to name this, we name it by using the two endpoints, okay? And its measure is equal to the measure of the related central angle. So here's what I know. okay, I would write this. I could say this a couple different ways. I know that angle AOB, okay, and that's this angle right here, is equal to 110 degrees. Okay, now the other thing that I could say is I could measure that arc, okay, and I could say that the measure of arc AB, and how I write that is I write AB with a little arc above it, and I would say that that is 110 degrees, okay, and that's my minor arc, okay. Now my major arc here, all right, and let's highlight that over here in this, okay, in this angle measure, okay, here's your major arc, your minor arc. Your major arc is you taking 360 degrees, which is the total revolution here. So 360 degrees divided by, minus 110, which is going to give you 250 degrees. So I know that this arc here, or this angle measure, is 250 degrees. Okay, so I would say that, you could also come in here and say that angle AOB, okay, so this is the small angle, okay, the small angle, this is the big angle, all right, this angle AOB is equal to 250 degrees, okay, so then if I wanted to measure my arc, I would say the measure of arc, and I'm going to say this, ACB, because C is a point that's included on that arc, okay? And I'm going to put my arc measure over the A and the B, okay, to show that I'm talking about an arc. So the measure of that arc is equal to 250 degrees. You get the same thing, okay? So it's just two different ways that we can talk about those arcs, okay? All right, so now let's move on to the next page. Okay, so we have this thing called the Arc Addition Postulate. It means that we can add all of these different arcs together and get a sum of those arc measures. Okay, so the measure in arc formed by two adjacent arcs is the sum of the measure of the two arcs. So what I can say here is I've got a number of different arcs here, but I'm going to highlight my different minor arcs. So I've got arc CD, okay, I've got arc DE, and then I've got arc EC, okay? And so here's what I know, okay? If I were to take the measure of arc CD, okay, if I were to add that to the measure of arc DE, okay, put a little arc mark above that, and add it to the measure of CE, so the measure of EC, let's use that, EC. Okay, if I add up all those arc measures, I'm going to get a total of 360 degrees, okay? And so I can add up any, arc measure here. I can add CD and get CDE, or CD and DE to get arc CDE. All right, so let me write that. So I could say the measure of arc CD, okay, if I add that to the measure of DE, okay, if I add just those two together, then I'm going to get the entire arc, the measure of arc CDE, okay, this arc here, all right, and it'll give me that. So you can add them together, you can kind of do whatever. I'm just going to do one example because you can do many different ones. But I do want you to know that if you add them all together, you should get 360 degrees, okay? So let's go ahead and let's answer this question here. It says, if AE and CD are diameters of circle B, then we want to find the measure of, find the arc measure of DE and find the arc measure of CE, okay? And then we want to find the measure of arc FAE, so the big one. Okay, so the first one I'm going to do is kind of figure out what all these interior angles are. So all of these add up to, these are diameters, so I know that this is 180 degrees. This is a diameter, so I know that this whole thing is 180 degrees. Same thing with these angles. Okay, so I also know that this angle down here, okay, is a right angle, so this is 90 degrees. Okay, now this is 50 degrees. This we don't know, and this is 90. Okay, but the whole thing has to add up to 180. So if I take 180 and I subtract off 90 and I subtract off 50, okay, then that's going to give me a measure of 40 degrees. So I know that this interior angle here for CBF is going to be 40 degrees, okay, because these angles have to all add up to 180, okay. Now the other thing I know is that CD and AE are diameters. So I know that these two angles here are congruent because they're vertical angles. So I know that this angle here is 50 degrees, okay? Now the other thing that I know is that since this whole thing is 180 and this is 50, I can conclude that this angle here is 130 degrees, okay? So that's one thing that you need to do first, is figure out all those angle measures, and then we can go on and figure out what those arc measures are, okay? So let's find the arc measure of DE. Let's do this one first, okay? So this one right here and that one here. So I'm just going to say that the measure of arc DE, okay, is just equal to the central angle that it has, which is 50 degrees. And that's it, okay? That's all we need. Okay, now the next one I need to do is the arc measure of CE. So I'm going to do that. So the measure of arc CE is equal to this angle here, which is 90, and then 40, so 40 plus 90, all right, degrees, which is going to give me a measure of 130 degrees. And that's it. That's all we're doing. This is 130 degrees, okay? Okay, the last one we want to do is the arc measure of FAE. Now that starts over here at F, it goes all the way through A, and then all the way to E. Okay. Now what I know, okay, I'm going to say this over here, the measure of arc FAE. Okay, and that's going to be 40 plus 50 plus 130. Plus 50. And all I'm doing is adding up these interior angles here, okay? And so we're going to end up getting 270 out of that. Okay, and the other way that I kind of did that was I said, all right, well, that's 3/4 of a circle. If the whole thing is 360 degrees and I subtract off 90 degrees, then we're left with 270 degrees. Okay, so it's a lot of just looking at a circle and answering some questions. So I hope you enjoyed this video, had a lot of fun making it. We'll see you later. Bye.